Welcome to this training guide for the Storm Prediction Center Tornado Damage Intensity Tool. My name is Kevin Scow from the Central Region Convective Warning Improvement Project, and this presentation will be broken down into two parts. The first focusing on an overview of the tool and how to use it, and the second section delving into case studies that utilize this tool. A little bit of background about the tool. It was developed by the Storm Prediction Center over the course of 6 years from 2017 to 2022 to answer the simple question of can we skillfully and quickly diagnose the current EF rating of a tornado in near real time. And this tool exclusively utilizes the damage assessment toolkit with over 56,000 damage indicator points through 4,000 different tornadoes. And this tool outputs an expected maximum wind speed range in which roughly 2/3 of the tornadoes within this sample data set fall within. And this is designed to give forecasters a baseline wind speed range estimate for making IBW tag and IDSS recommendations to partners. Some things to remember about this tool: it has no predictive capability. It is purely a diagnostic tool using current radar and environmental data. And really, it shines in the range between real-time warning decision making and storm survey planning. It should only be used once a tornado is confirmed and ongoing. It cannot be used, like say if you have a mesocyclone going for a number of scans before a tornado is reported. That can't be used in the utilizing of this tool. This tool will suffer from the same limitations as the EF scale, such that a rural tornado interacting with limited damage indicators will likely appear stronger in the tool than the eventual storm survey reveals. It does not explicitly diagnose tornado intensity, which is why it's called the Tornado Damage Intensity tool, as numerous mobile radar studies have shown that storm surveys tend to rate tornadoes lower than what their radar data would indicate. The tool is very sensitive to VROT calculations, and care should be taken to accurately ascertain these values. And given the workload with this tool, it should not be used by the warning meteorologist. This is a great tool to be used by, say, a warning assistant or a local mesoanalyst, and really is designed to, again, sway those IBW decisions for primarily the more extreme outliers, like say having only a base warning when the data in this tool would suggest an EF4 or greater tornado, and vice versa, like say if you have a catastrophic tag and the data is pointing more towards an EF1 tornado. This tool is entirely housed within a web browser that can be accessed at the link here at the bottom right of the screen, and can be broken down into 4 main sections, such as the user input, statistics table, and then some decision trees and histogram sections. And we'll go over what each of these sections are and how to use them more in the upcoming slides. First, the user input panel. This is where you'll be inputting your data to get the output from the tool. You supply your VROT duration, your significant tornado parameter, population density, and TDS signature. And we'll go over how to use each of these inputs here in a little bit. The bottom left section is more of a statistics table and output where it shows your wind speed ranges here. And then maybe some text you could possibly use for internal collaboration with partners to talk about what we might be expecting the tornado to be doing. And the bottom table has a variety of statistics, including an IBW tag recommendation and relative frequency that we tend to see these signatures in the data set. The middle section of the tool is a set of decision trees, and these are identical in that they're driven by STP on the x-axis and VROT on the y-axis. The only difference is that the top one is color-coded by EF scale, and the bottom one is color-coded by the IBW tag recommendation for warnings. And the dark black box indicates where your inputs lie within this decision tree. Finally, the right-hand section shows the raw data set broken down by the conditional probabilities that you see for your various inputs, broken down by EF scale. And the bottom is the raw histogram broken down into 5 mile-per-hour increments bins, so you can see exactly where every tornado in the data set lies relative to the IBW tag recommendation, which is color-coded here in the red. Again, VROT is a key driver for this tool and also the most susceptible to user error. And so the criteria was rather strict for ascertaining the VROT values used in this data set. First of all, the max distance from the radar was 100 nautical miles or less than 10,000 feet ARL. So the signature has to be below this level or within or less than 100 nautical miles away to be usable by this tool. Also, we want to be wary of side lobes, so there was a reflectivity limitation of greater than 20 dBz, greater than or equal to 20 dBz, and correlation coefficient greater than or equal to 95% to weed out those side lobes. Now, of course, the exception would be if an identified tornadic debris signature was present, we'd have to relax that CC requirement. The signature would have to exhibit cyclonic azimuthal shear, and the distance between the two maxima velocity values for ascertaining the VROT had to be within 5 nautical miles and equal to or less than 45 degrees of a line orthogonal to the radar beam. So in this example here, on the bottom right, your radar is off to the northwest. So you would draw a line orthogonal to the radar beam, and you would look within 45 degrees on either side of this line for determining where you would be able to pick your VROT value. And so any areas within the black hatching obviously would be excluded from that VROT calculation. Other minor notes, if there were two maxima observed, then we would use the inner maxima. And also in rare cases, if the half-degree data was contaminated, you could use the 0.9-degree scan in its place. Again, some helpful hints for determining VROT. Be very wary of side lobes, as these can dramatically throw off your VROT calculations. The side lobes will appear broad and blocky, and generally in areas of low reflectivity and low correlation coefficient. The tool was not designed to use spurious pixels, so look around your data, make sure the data makes sense. If there is just one spurious pixel surrounded by much lower data, probably throw that one out because it's probably not realistic. Check for that vertical and temporal continuity in the signature, and if there's any ambiguity, probably don't want to use it. And really hone in as tight to the tornado as possible and look at the storm structure, look at the location. Does everything make sense that this is where the tornado should be in the storm? For sampling rotational velocity, there are two ways to do it. The first is within AWIPS. Load the velocity or storm relative velocity product in D2D, go to your tools, and then go to the VR shear tool and draw a line between your two maxima so that the two endpoints are on each end of your maxima, and VROT will be the value given here on the first value in the string here, shown here in the yellow box. If you're using the Gibson Ridge product, load the VSRM tool, VRSRM product as well. Place a marker, the red dot, on one of the circulation maxima, and then hold down the control key and move your mouse to the other maxima you want to sample, and VROT will be shown here in the pop-up box towards the middle to bottom of the screen here, along with other useful information about the circulation. Moving down in the tool, the next item on the list is the rotational velocity duration. And this is the total non-continuous time of VROT values equal to or greater than the VROT range that you provide in the first step. And this is a bit of a mouthful. And so I highly recommend going through part 2 of this training to see examples of how to utilize this. And if the VROT range band increases, so if we go from, say, 45 knots to 65 knots, this counter will need to be reset as it's only applicable to the range that you've selected up here at the top. Now you'll notice there's both a temporal counter aspect and a scan counter aspect to that selector. And the scan counter part was designed to be used with Mesosales 3 data. So if you're using anything less than that, you'll probably start noticing a discrepancy creep up. And if that happens, the time part of the selector trumps the scan count if, again, any discrepancy builds up. Below that is the significant tornado parameter, the effective STP, which is simply a composite parameter taking into account mixed layer CAPE, SIN, LCLs, effective SRH, and bulk wind difference. And this tool is calibrated to the max STP value within 80 kilometers of a tornado location. And that's important because the background for this tool is the RAP 40 kilometer model, and tornadoes like to occur along gradients in the environment and thus gradients on the STP. So there's a wider net cast to better reflect the environment the tornado is likely experiencing. And you need to be wary of bad mesoanalysis data and don't always take the exact STP values at the tornado location. And if you feel the effective STP is unrepresentative of the environment, you're allowed to use the fixed layer STP in its place. Finally, the last sections of the tool, the population density boosts the potential wind speed ranges for only the strongest subset of the tornadoes in this data set. Those tornadoes with a VROT value of at least 70 knots and an STP of greater than 6, essentially saying if you have a violent tornado that is entering a populated area with a greater concentration of damage indicators, that the possibility of having an EF4 or EF5 increases. And this doesn't change anything with tornadoes lower than this subset right here. The tornadic debris signature is not used by the tool in calculating anything, such as the wind speed or IBW recommendations. It only is a sanity check for the forecaster to confirm that a tornado is in progress. So that wraps up a review of the tool. Again, I highly recommend going to part 2, the case examples, to show how to use this tool properly. And again, thanks for joining.